Alright, so for our first problem, we had a plot where this ice cream shop could be. So we were given where our house was. It was at 1 and 3, and then we were given Main Street, which was it's going to be 4 blocks away, somewhere on Main Street. So the first thing I did was plotted those, and then I drew like a half circle to kind of approximate where my points would be. And then I had the information that I knew. I knew x1, y1, and x2, but I didn't know y2, and that's what I wanted to solve for. So I plugged all that information into the distance formula. And then I got it into this format so that way I could plug it into the quadratic formula. And then I did a lot of algebra and stuff, and I ended up getting 0.35 for y, or 5.65. And then if you look at my graph, it matches up pretty well. So the possible places that the ice cream shop could be are at 4 and 5.65 and 4 and 0.35. So the second question was, explain how you know that you can or cannot create a platonic solid out of regular hexagons. So I said you cannot create a platonic solid out of regular hexagons because to tessellate a plane with regular hexagons, you need 3 regular hexagons, and then if we were to take one away, so say we take one of these away from the vertex, it wouldn't be able to support a three-dimensional figure because if we try to put these together, they would just collapse on themselves. So no 3 regular hexagons would not be able to make a platonic solid. So for number 3, we had to figure out if it was a pyramid or a prism. And to do that, I knew we had 15 vertices, and so I used like my n-gonal formulas, and I used n plus 1 to figure out how many sides my shape would have, and I figured out it would have 14 sides, and then I used like the other formulas to figure out the other answers. So faces, I got 15 faces, and edges, I got 28, and then I plugged it into Euler's formula to make sure it like equaled each other, and I was like, okay, this could definitely be a pyramid, but let me check if it could be a prism. So I did the same exact like method. I used these to figure out how many sides it would have. So I plugged the 15, or I did 15 equals 2n, and then I got n equals 7.5, but you can't have 7.5 sides, so I realized it would be a 14-gon pyramid. So for question 4, we had to make a 3D figure of this right here. So this is my 3D figure, and it said right there that where the 4 blocks is, that's going to be the front. So this is the frontal view. There's not a lot of explaining I needed to do here, so I mean, we could turn it around and stuff if you want. But that's basically what it looks like, and then this right there is the front. So question number 5 was probably the most like involved question. So the first part, we had to find the side length of the triangular base. So there was like a lot of steps I did before that. So the first thing was I found the volume of the cube that flew into the dice. And I got 4.096 cube centimeters, and then I knew that volume would be the same as the volume of like the little piece that like rose up, like that little sliver is that right there. I did my best drawing. And so I also knew that the height of that would, like this little part, was 0.03 because that was given to us. So then I used that to find the area of our base, because like I plugged my volume in and I plugged my height in, and then I just wanted to find the area of the base, so I did some algebra, did all that, and then I got the area of the base to be 136.53 squared centimeters. So then moving on to find like the side lengths, so I drew my little triangular base, and then I wanted to find out what my height was. So to do that, I used this is x 1/2 x, and then I did the Pythagorean theorem because I dropped that down to be a right angle, and I did some algebra and stuff, and I got my height to be the square root of 3 divided by 2 times x. And then I used that and plugged that into the triangle formula to find the area. And so I knew my area already, and then I plugged in everything else that I knew, and I wanted to find what x was because that would give me my side length. And then for my side length, I got 17.76 centimeters. So after doing all that, it was pretty smooth sailing. So I needed to find the surface area, which is usually 2 times b plus p times h, but we only needed one area of the base because it was a cup, so one of the areas was empty. So I plugged in my information. I knew that 136.53 was the area of our base, and then to find the perimeter, I just added our side lengths together, so it was 17.56 times 3, so 53.28 times 12, which was our height of the whole cup. And then I ended up with the surface area being 775.89 square centimeters. And then for C, I needed to find the volume, which is the area of the base times height. So I did 136.53 times 12, and I got are 1,638.36 cube centimeters. All right, so for our last question, it was a sphere has a radius of r, a cylinder has a radius of r, and a height of 2r. These two figures, surface area and volume, are related in a particular way. Suppose you know how to find the surface area and volume of a cylinder, but you do not know the formulas for the surface area and volume of a sphere. You do, however, know what the relationship is. Find the formula for the surface area and volume of a sphere using the given information. Alright, so what I did was I drew a cylinder, and then I drew a cylinder with like a sphere inside of it, and I labeled my radius, which we knew, and then I labeled my height, which we also knew was 2r, and then I knew that the relationship was the volume of a sphere is equal to 2/3 the volume of a cylinder, and then the surface area of a sphere is equal to 2/3 the surface area of a cylinder. So what I did was I knew that the surface area of a cylinder was 2 pi r squared plus 2 pi r h. So I needed 2/3 of that because that's how I was going to find the surface area, the surface area of a sphere. So I multiplied that equation by 2/3, and I plugged my height, or 2r, in for my height, and then I just did some simplification, and I got my surface area for a sphere to be 4 pi r squared. And then I did kind of the same thing for the volume of the cylinder. So I knew that it was pi r squared times h, and I substituted in 2r for h. And then I knew that for the volume of a sphere, it was 2/3 of the cylinder. So then I multiplied that by 2/3, and I did some simplification, and I got the volume of a sphere being 4/3 pi r squared.